Okay, now finally I want to talk about buoyancy. So when we talk about buoyancy, what we're going to talk about is the force of an object immersed in a fluid that's pushing it up out of the fluid. All right, so buoyancy is always going to sort of push something upwards and try to counteract gravity. It might not win, does not have to win, but it will try. It'll do its best. All right, so the buoyant force lifts an immersed object due to the pressure difference in the fluid from its top and its bottom. Okay, so what does that mean? That means if I have something like this, right, there is a lower pressure here. Remember, the pressure was rho g d, right? So there's less pressure here than there is here, right? Because there's less pressure here than here, then we're going to have a difference of force. So last time we said there was a force, so on this top one here, right, we have a large force, let's say, from the water, P top, and then there's a force coming up here, P inside, right? And this is going to push upwards, right? And this is going to push downwards, but the net effect is going to be down, right? Right, P top minus, or P in minus P top, okay? Then we come to the bottom part here, we have P in over here. So the interior, the force isn't really changing very much, the pressure isn't changing very much. And then on the bottom we have a larger force pushing up because it's farther down. It has a larger force, so that's P bottom minus P in. We add those two forces, the insides cancel, and you just get the pressure from the bottom minus the pressure from the top. Okay, so what that means is that you have a PGD from here minus a PGD minus H from here. So this is the height. So we get, or it should be rho, I'm sorry, the density times G times the height of this cylinder. Okay, so that's what's causing that pressure difference, or that's what's causing that buoyant force, the pressure difference. Okay, so we have that buoyant force, and this is the way it's usually written. We could go into more detail, but let's not. The buoyant force is equal to the fluid density, the volume of the fluid here, times the displaced volume, the amount of which is, we'll talk about that more here. In case of the immersed object, the volume is the entire volume of the object, times the gravitational acceleration. It's sort of like the weight of the displaced water. If you're completely immersed, this volume is the volume of the object. But that's not always true. Sometimes you have this situation, right, where you have a floating object instead of an object that's completely sunken, right? And in that case, it's only this volume that's under the water line that's pushing the object up. Another way to look at that was, remember that the pressure was the atmospheric pressure plus the gauge pressure. So the pressure right here at the top is just the atmospheric pressure. The pressure at the bottom is the atmospheric pressure minus the, or plus the rho GD. So when you take the difference between these two, the top and the bottom, you just get rid of the atmospheric pressure, and it's just the rho GD that's causing the force pushing up. So that volume is just the volume around here, and the pressure at the top, this pressure is P atmosphere. The pressure here is P atmosphere, it doesn't matter. Everything in that gas, the pressure equilibrates. So that's the difference between a gas and a fluid, as far as a physicist is concerned, is because of the fact that a gas can fill a space. It has the pressure the same anywhere, or it has the pressure the same anywhere, so it can change its density in order to keep the pressure the same. Whereas the fluid can't change its density, so its pressure changes, but its pressure changes, but the density stays the same. For the gas, it's the other way around. The pressure stays the same, and the density changes to compensate. All right, so that's what we mean about our buoyant force, is that it's the force of the water at the bottom of the object pushing it up minus the force at the top pushing it down. For an immersed object, for a sunken object, you have all this. The entire volume of the object is pushing water away. The entire volume of the object is displacing water. Whereas if it's floating, then it's only the water, it's only the volume under the water line that you have to worry about. All right? Bye now.